Hey guys, let's solve Leetcode 61 rotate list. Given the head of a linked list, rotate the list to the right by k places. So let's take the first example, right? As you can see, we have this linked list, right? So we have given k is going to be 2, right? So we are going to rotate the first two nodes from the right. So we have going to take these nodes and we are going to bring them to the first part of our linked list. As you can see, they are in the beginning, right? And as you can see, the rest of the link, the part of the linked list is gonna be the end, right? It's going to be in this position. So so what if k is going to be 0, right? What if we have given k is 0? We are going to take 0 elements from the right. So taking 0 elements from the right means it's going to affect, we're not going to take we are not going to rotate any node, right? So the linked list is not going to change, right? So what if we are asked to rotate the first 5 elements from the right? What if we have given 5, right? So this means we are going to take all the nodes and bring them to the first part of the linked list. And as you can see, if we take this part of the linked list, all of them, as you can see, if we take all of them, and there is no other part of the linked list remain, right? So this is going to be just the original linked list, right? It's not going to be different. So as whenever k is 0, that means we can just mod k by the number of nodes in the linked list. As you can see, if we mod 5 by 5, it's going to be 0, right? So it means like we are taking 0 elements from the right. So taking 0 elements from the right means it's not going to affect the linked list, right? It's going to be the original linked list because we are taking 0 element, 0 node, right? That means we are not rotating, right? So because we have to make a modulo operation is because then the k can be as large as 2 times 10 to the power of 9, right? So but how many nodes we have? We have only 500 nodes, right? So we have to make a modulo operation, right? So how do we solve this problem? How do we rotate them, right? So the first thing what we are going to do is we need to have, let's say I have a pointer, right? Let's say I have a second pointer. So it was at the head of the linked list. I mean, it was initially out of this, was here, right? Then, then I'm going to move this second pointer all the way to, I'm going to move this, let's say I'm going to move I have a second pointer. I'm going to move this second pointer all the way to k steps from the right. So s was initially in the first node. For example, for k is equal to 2, I'm going to move s to 2 steps from the right. So it's going to be in this position. So once I know where the second pointer is, now I'm going to have another 2 pointers. For example, I have this first, and I'm going to have a previous pointer, and a previous pointer is the previous of this first, right? This pointer. So I'm going to move all of them one step at a time. So let's move the second pointer to this position, right? It's going to be here. And the first is going to be pointing to this position, and prev is going to be here, right? Then the second pointer, when the second pointer is here, the first is going to be in this position, and prev is in this position. And when the second pointer is at the tail, the first pointer is going to be here, right? And previous is going to be here. As you can see, the first pointer is going to be, this pointer is going to be pointing to is going to be the head of the linked list. We have found our head, right? First is going to point our our new head, right? So let's say our new head is pointing to, our new head is going to be the first node, f, right? And the second pointer is going to point the head of the original linked list, right? Is going to be the head. So it's going to point the head of the linked list. As you can see, it's going to point to this node, right? And the next of the previous is going to be the tail of the linked list, right? Previous is going to be the tail of the the linked list. So it's going to be, previous is pointing to null, right? It's going to be pointing to a null linked list, null node, right? So Once we know this, we can just return the new head, right? Our new head is going to be the first linked list, right? We can just return this one. So the time complexity is going to be of n, and the space complexity is going to be of one, right? Just we just point the we point just the nodes to each other, right? So I'm going to go the implementation. So let's go to the implementation, right? So we're going to first we need to know the length of the linked list, right? We have to know how many nodes we have, right? So what we are going to do is first let's say n was the length of the linked list is 0. So first we need to know like if 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 there is no node in our linked list, if not hit, or if k is 0, we can just return the head, right? We can just return the head of the linked list, right? And what if, oh, otherwise we have to know n, right? And how many nodes we have. Like, let's say our current is going to be in the head while is cur, and so n is going to be increment by 1, then cur is just cur go next, right? Then once we have done this, the first thing what we know, let's say I have a second pointer, I have a second point was initially none. Then what I'm going to do is I'm going to let's say cur is again is the head. I'm going to remove the second pointer all the way to k steps, right? So in range of k, what I'm move is second is going to be cur, and cur is going to be the head of the linked list, right? I mean, cur is going to be cur dot next, right? So I have moved all the way k all the way. I have moved the second pointer all the way to k steps from the head of the linked list, right? Then then what I'm going to do next is I have first pointer. Let's say I'm gonna have a previous pointer. The previous is initially pointing none, and I'm gonna have a first pointer, which is the head, right? It's pointing the head of the linked list. Okay, then head. So while second, and I'm going to move second all the way to the last node and the linked list. So second is going to be, so next what we're going to do is just previous just the first pointer, right? And first we have to move the first is going to be first dot next, and the second pointer moves second dot next. Okay, then once we have done this, if the second pointer is not none, if it is not none, new node is going to be, I mean, new head is going to be first, right? First is going to be our new head, and previous dot next is going to be none, right? And then the second node, the tail, I mean the second node dot next is going to be the head of the original linked list. Otherwise, if just the second is none, we can just return the head of the linked list, right? Instead of yeah, or we can say like new head is going to be new head, or let's say we have new head is going to be the original head, and return just the new head, right? So the other thing what we can do is, oh yeah, we have, once we know the length of the linked list, the number of nodes in the linked list, k has to be mod. We have to mod k by n, right? But if k is n, if k is zero, we can just return the head, right? The head of the linked list. So as you can see, the time complexity is going to be the number of nodes in the linked list. So in time complexity is going to be the number of nodes, so it's going to be of n. Then space complexity is going to be of 1, right? So it's going to be of 1. So let's see if this works for the test case. Okay. So as you can see, passed for the given test cases in this example, and let's see if this works for all of them. Okay, it passed for all of the test cases. So guys, if you like this video, please subscribe. It's gonna be it's going to help me a lot. Thank you very much.